Have you ever considered the invisible energy tax that some components levy on your electronic circuits? It is a subtle yet significant factor that can dramatically influence a device's performance and longevity. Forward voltage drop directly impacts diode selection by dictating the power loss, heat generation, and overall efficiency of a circuit. This is especially critical in rectifier designs where every millivolt matters for optimal operation. The why behind this is fundamental. A diode is not a perfect conductor. It requires a certain voltage across its terminals, known as the forward voltage or turn-on voltage, before it will permit significant current flow. Once conducting, this forward voltage remains across the diode. This voltage, multiplied by the current flowing through it, represents power that is dissipated as heat within the diode itself. For example, a common silicon diode typically exhibits a forward voltage drop of around 0.7 volts. In contrast, a Schottky diode, known for its fast switching and lower voltage drop, might only present 0.2 to 0.5 volts. This difference might seem small, but under high current conditions, say 10 amperes, a 0.5 volt difference translates to 5 watts of additional power dissipation. This heat must be managed, as excessive temperatures can degrade diode performance, shorten its lifespan, and even lead to thermal runaway. The specific material and doping of the semiconductor junction, along with the device's operating temperature and current, all contribute to this characteristic forward voltage drop, which is also depicted on its current versus voltage curve. So, how do we use this knowledge? When selecting a diode, first determine the maximum current that will flow through it. Next, consult the diode's datasheet to find its typical forward voltage drop at that expected current. Calculate the anticipated power dissipation using the formula power equals forward voltage times forward current. This calculation helps you choose a diode with an appropriate power rating and aids in designing necessary thermal management solutions like heat sinks. For applications where efficiency is paramount, such as battery-powered devices or high-power rectifiers, opting for diodes with lower forward voltage drops, like Schottky diodes, is often the best choice, even if they might be slightly more expensive. An insider tip for robust designs involves understanding not just the nominal forward voltage, but also its variation with temperature and current. Many engineers overlook the dynamic nature of this parameter, which can lead to unexpected thermal issues. Moreover, while we focus on forward drop, it is also worth noting another critical characteristic: reverse recovery time. While not directly related to forward drop, it describes how quickly a diode can switch from forward conduction to blocking reverse voltage, and Schottky diodes also generally excel here, making them ideal for high-frequency switching applications like switch mode power supplies. Considering these characteristics together elevates your circuit design from functional to truly optimized. Ultimately, selecting the right diode based on its forward voltage drop is for more than a simple component choice. It is a fundamental engineering decision that directly influences a circuit's energy efficiency, its thermal performance, and its long-term reliability. By carefully considering this characteristic, you empower yourself to design electronic systems that are not only effective but also robust and highly optimized for their intended purpose.